In engineering practice, a system with variable output is often classified as unreliable. A system with smooth, consistent performance is classified as safe. But performance variability and system failure risk are not the same quantity. Variability measures how much output deviates around a nominal operating point. Failure risk measures how close the system trajectory is to an absorbing failure state. A high variability system far from its failure threshold is not at high risk. A low variability system with degrading safety margins may be approaching structural failure. These are distinct failure modes that require distinct monitoring approaches. Performance variance measures the symmetric spread of system outputs around a nominal value. An overperformance deviation and an equivalent underperformance deviation contribute identically. The measure has no concept of direction. It does not register whether successive outputs are trending toward a failure threshold. Variance measures dispersion in the output distribution. It does not measure distance to the failure state. A system oscillating widely within safe margins and a system degrading smoothly toward failure can produce identical variance statistics. System failure risk is defined by the trajectory approaching an absorbing failure state. Structural failure, capacity exhaustion, and safety margin collapse are absorbing states. Once the system crosses the failure threshold, the trajectory does not recover. This structure is asymmetric. Only the crossing into irreversible failure matters. A system degrading toward that threshold carries risk regardless of how stable its output appears. Direction and distance from the failure threshold determine structural exposure. Output variance does not. A system can exhibit high performance variance while remaining structurally safe. If the output fluctuates widely but the safety margin to failure remains large, structural risk is low. The variance is real. The oscillations are large. But each excursion remains far from the level at which irreversible failure begins. Margin to failure is the relevant safety quantity, not the amplitude of performance variation. Consider a system whose output metrics barely change from cycle to cycle. Variance is near zero. Performance appears smooth and controlled. But if the underlying safety margins are degrading steadily, structural failure is approaching without visible warning. This pattern appears in aging infrastructure, fatigue accumulation, and slow capacity erosion. The apparent stability of output variance masked the approaching failure threshold. Reliability metrics based on variance cannot detect this mode of deterioration. Reliability metrics based on output variance fail to detect trajectory-based failure risk. The limit state function in structural reliability defines failure as margin reaching zero. This is a distance measure, not a dispersion measure. A system with low output variance can have a limit state function approaching zero throughout its operating life. Variance-based metrics will report it as reliable until the moment of failure. To manage structural risk, monitor margin to failure. Variance describes output spread. It does not describe structural distance from the absorbing failure state.